Welcome to Spelling Bee Ninja, your go-to podcast for free educational content. Join our vibrant community of learners as we explore exciting topics while striving for mastery and understanding. Don't forget to subscribe so you never miss out on our next empowering lesson. Today, we're diving into the fascinating world of probability, understanding chance and how it affects our daily lives. Let's kick things off by understanding what probability is. Probability is a branch of mathematics that measures how likely an event is to occur. Imagine flipping a coin. There are two possible outcomes, heads or tails. The probability of landing heads is 1 out of 2, or 50%. Mathematicians express this as a number between 0 and 1, where 0 means the event is impossible, and 1 indicates certainty. So, the coin flip is a great way to understand probability in action. Did you know? The modern theory of probability emerged in the 17th century, sparked by mathematicians trying to solve gambling problems. Next, let's talk about how we actually calculate probability. The formula is quite simple: you divide the number of favorable outcomes by the total number of possible outcomes. For instance, think about rolling a fair six-sided die. If you want to know the probability of rolling a 4, you have one favorable outcome, which is rolling that 4 out of 6 possible outcomes. Hence, the probability is 1/6, or approximately 0.16. This simple formula lays the groundwork for all probability calculations. Here's something interesting: the probability of an event occurring combined with the probability of it not occurring always equals 1. Now, let's delve into a special scenario. What happens when an event is impossible? The probability of an impossible event is 0. That's right, if something cannot happen, you have no chance of it occurring. For example, rolling a 7 with a standard six-sided die is impossible because the numbers range only from 1 to 6. Similarly, grabbing a red card from a deck of only black cards demonstrates an impossible event, too. Understanding these impossible situations helps us set realistic boundaries in probability problems. Fun fact: in probability theory, we refer to such events as null events or empty events. On the flip side, we have certain events, which have a probability of 1. This means these events are guaranteed to happen. Take the rising of the sun tomorrow, for instance. We can say its probability is virtually 1 when excluding astronomical uncertainties. Understanding such guaranteed events gives us insight into the upper limits of probability. Here's another quick fact: the probability of an event and its complement adds up to 1 as well. So, if an event is certain to happen, it's equally important to recognize what that means for other possibilities. Let's explore complements a bit more. The complement of an event occurs when the event does not take place. For example, if there's a 30% chance of rain tomorrow, the complement would be 70%, indicating no rain. Adding these probabilities together gives us 1, a crucial aspect of probability that helps us navigate complex problems. Did you know the complement rule is widely used in various probability calculations? Moving on, we encounter independent events in probability. These are fascinating because the outcome of one does not affect the other. Think about flipping a coin while simultaneously rolling a die. These are independent events. The result of the coin does not change the outcome of the die. For independent events, calculating the probability of both happening takes us to the multiplication rule. For example, flipping heads gives you a probability of 1/2, and rolling a 4 gives you 1/6. Multiply these two probabilities together, and you find the likelihood of both occurring is 1/12. For independent events, this rule serves as a valuable foundation in probability. In contrast, dependent events are those where one event influences the outcome of another. Consider drawing 2 cards from a deck without replacing the first one. The outcome of the first card directly affects the second. To find the probability of both events happening, we turn to conditional probability, represented mathematically as the probability of event A multiplied by the probability of event B given that A has occurred. Understanding dependent events is incredibly important in real-world scenarios, such as medical testing or risk assessment, where the outcomes can significantly impact subsequent decisions. Let's also differentiate between theoretical and experimental probability. Theoretical probability is what one expects to occur based on calculations before any real-world testing occurs. For example, the theoretical chance of flipping a coin and landing heads is 1/2. On the other hand, experimental probability is derived from actual data collected through trials. If you flip a coin 100 times and land heads 48 times, the experimental probability becomes 48%. Interestingly, as the number of trials increases, this experimental figure typically aligns closer with the theoretical probability. This phenomenon is backed by the law of large numbers. Moving on to real-life applications, the realm of probability extends far beyond academic exercises. Meteorologists employ probability methods to inform us of the likelihood of rain. In finance, actuaries use probability to assess risks, calculating premiums for insurance. In medicine, probability aids doctors in forecasting diseases' likelihood and assessing treatment effectiveness. Even in sports, coaches rely on probability to make strategic calls. In everyday choices, we unconsciously assess probability too, like when deciding whether to bring an umbrella based on weather forecasts or how likely we think it is to rain. Lastly, let's reflect on why probability has become such a significant branch of mathematics. We live in an unpredictable world, filled with uncertainty, and probability equips us with tools to navigate through it. It plays an essential role in understanding weather patterns, forecasting economic trends, making informed medical decisions, and ensuring the safety of engineering projects. Probability is the cornerstone of modern statistics, machine learning, and artificial intelligence, essential for various fields. Interestingly, what began as a method to comprehend games of chance is now a critical component of nearly every area of human endeavor, indicating the profound impact that probability has on our world today. To sum it all up, probability helps us understand the likelihood of events happening, with important concepts such as impossible events, certain events, independent and dependent events, as well as the distinctions between theoretical and experimental probability. Probability helps us not only in academic contexts but also in practical decision-making in everyday life and professional fields. With its rich history and diverse applications, it's clear that mastering probability is essential for navigating a world filled with uncertainty. Thank you for joining us today on this exploration of probability. We hope you found this lesson insightful and engaging. If you enjoyed today's topic, be sure to subscribe to Spelling Bee Ninja for more educational content. Until next time, keep learning and questioning the world around you.